The production of channel catfish has increased steadily in the United States over the past 20 years. Production of food-sized fish is directly dependent on a ready supply of fingerlings to stock into production ponds. This program is intended to explain the procedures used for fingerling culture, from the care of broodstock until the fingerlings are ready for stocking into grow-out ponds. Researchers or producers who want to maintain or improve a genetic strain of broodfish commonly use pens or aquariums. They pair specific males and females for spawning. This gives maximum control over the spawning process, but requires large investments in special equipment and a high level of management skill. Small-scale producers who need relatively few fingerlings or face labor limitations sometimes use the rearing pond method of spawning catfish. Here, broodfish are allowed to spawn and incubate naturally. Then either the broodfish or fry are seined and transferred to other ponds. Most commercial catfish producers use the pond spawning egg transfer spawning method. This includes a spawning phase and a hatchery phase. During the spawning phase, broodfish are allowed to select mates and spawn in a nearly natural environment. In the hatchery phase, fertilized eggs are transferred from spawning ponds to a hatchery facility with the best conditions for egg survival and fry growth. The pond method requires skilled management and a relatively high initial investment, but it offers the most cost-effective means of producing large numbers of fingerlings. Let's focus on management practices for the pond spawning method. Getting quality broodfish is the first requirement. When catfish aquaculture began, broodfish were captured from streams and lakes. But today, catfish are selectively bred for improved weight gain, feed conversion, and disease resistance. In the last 50 years, breeders have developed nearly 200 distinct genetic stocks of channel catfish. Commercial catfish producers don't spawn wild-caught broodfish. They tend to be unreliable spawners and may harbor diseases. Their offspring may not grow as quickly as those spawned from improved stocks. Broodfish represent a major investment. Before purchasing, inspect broodfish individually to ensure that they are in good condition and free from disease. Finfish may be diseased, underfed, or too old to produce well. Never accept fish with skin lesions or parasites on the skin or gills. Broodfish purchased in the breeding season should show obvious secondary sex characteristics. Males usually have a larger, more heavily muscled head, thicker lips, and darker body pigmentation than females. Females have a smaller head and mouth. When viewed from above, the male's body is somewhat tadpole-shaped. Females should have a full, rounded abdomen that extends back to the genital opening, which should be swollen and pink or reddish in color. Outside the spawning season, examine the genitals to make final sex determinations. Turn the fish belly side up. You will see two openings. The one closest to the head is the anus. The opening nearest the tail is the genital opening. The male's genital opening is round and looks like a small raised nipple. The female's genital opening is oval in shape and lies nearly flat against the body. It has two openings separated by a flap of skin. Eggs are laid from the front opening, which looks like a slit or a groove. Broodfish size is also important. Channel catfish may be sexually mature by the time they reach 1 pound, but most producers prefer broodfish between 2 and 10 pounds. Fish smaller than 2 pounds generally produce too few eggs, and fish larger than 10 pounds are hard to handle. Broodfish management is a year-round job. Provide your fish with adequate nutrition and good water quality throughout the year, not just during the spawning season. Underfeeding or overstocking to reduce production costs will probably result in fewer and smaller eggs. Do not stock more than 1,200 pounds of broodfish per acre at any time, regardless of their size. Producers often stock 600 to 800 pounds per acre to allow for growth and provide a margin of safety in case of water quality problems. It is best to divide brooders among 2 or more ponds, so that some eggs will be produced even if disease or oxygen depletion strikes. Broodfish need a diet that contains at least 36% crude protein. When the water temperature is above 70 degrees, feed broodfish as much as they will eat in about 15 or 20 minutes every day. Use a floating type feed so you can watch the fish feeding and determine how much feed to offer. When water temperatures are between 55 and 70 degrees, feed 1% of body weight at least 3 or 4 times weekly. 1% of body weight should be fed as a maintenance ration when the water temperature is below 55 degrees. Many producers also supplement pelleted feeds with cut fish or live forage fish such as minnows or goldfish for additional protein. When spawning begins, feeding activity decreases. Careful management is needed to meet but not exceed the feed requirements of broodfish at this time. Overfeeding can reduce water quality. This stresses the fish, reduces egg production, leads to disease outbreaks, or causes a fish kill. To avoid these problems, feed only as much floating feed as the fish will eat in 10 minutes. Transfer broodfish from holding ponds to spawning ponds during the late winter or early spring. At that time, determine the sex of each fish and stock males and females in proper proportions. Many producers stock 3 females for every 2 males because a male channel catfish will usually spawn with more than 1 female. Not every female will spawn and all eggs will not survive. But good managers can produce 800 to 1,000 fingerlings per pound of healthy female broodfish. Plan accordingly by matching your broodfish program to the number of fingerlings needed to meet your production or marketing goals. Containers such as 10-gallon milk cans, earthenware crocks, plastic barrels, or wooden boxes provide nesting sites for spawning catfish. Place them in spawning ponds before broodfish are stocked, or at least 1 month before the water temperature stabilizes at 70 degrees. Spawning containers should be large enough to accommodate a pair of broodfish. They should have a smooth-edged opening in one end, just large enough for a fish to enter. The other end should be completely closed. Never use containers that have held pesticides, herbicides, or other potentially toxic materials. Place the containers 3 to 10 yards apart in water 2 to 3 feet deep. Place them with the open end facing the center of the pond. Mark the location of each container with a float or a stake. All fish don't spawn at the same time, so you need not provide a container for every pair of fish. Most producers provide 1 or 2 containers for every 4 pairs of broodfish. Well, let's follow the spawning process. As water temperatures increase, male catfish select a spawning container and attract a mate. The spawning pair lies side by side and head to tail in the spawning container. The female releases several hundred eggs at a time. These are fertilized simultaneously by the male. Spawning may take as long as 20 hours to complete. Fertilized eggs sink to the bottom of the container and form a single mass. Shortly after spawning stops, the male drives the female out of the nest and cares for the eggs. He protects the eggs from predators and gently fans and moves the egg mass to provide enough oxygen to all the developing eggs. The female's work is done. Soon after spawning has ended, the fertilized eggs are removed from the spawning container and transferred to the hatchery. Proper timing and management are important. Check spawning containers every other day for eggs when the water temperature stabilizes at 70 degrees. Check the containers daily when the spawning season is at its peak. Gently raise the open end of the container, look in the opening, and remove eggs if necessary. Be careful because male catfish aggressively guard their eggs and can bite severely. Eggs collected at the proper time are yellowish in color and stick together to form a single mass. Transport the egg mass whole if possible. If necessary, use something like a plastic spatula to gently scrape the eggs from the bottom of the spawning container. Catfish eggs are sensitive to physical, chemical, and thermal shock, so move them as quickly and gently as possible. While at the pond, use a covered floating tub to protect the eggs from direct sunlight. For the trip to the hatchery, place the eggs in a hauling container that minimizes water movement and mechanical damage. If the water temperature in the hatchery is more than 5 degrees different from the spawning pond, temper the eggs slowly during transport. Catfish eggs require a dissolved oxygen concentration of at least 3 parts per million. Use oxygen gas diffused through air stones when eggs must be held for more than a few minutes during transport. Back at the hatchery, place the eggs into hatching troughs. They may be fiberglass, wood, metal, or large diameter PVC pipe cut in half lengthwise. A good size for hatching troughs is about 8 feet long, 18 to 24 inches wide, and 10 to 12 inches deep. An internal standpipe keeps the water at a depth of about 8 inches. Adequate oxygen concentration is also essential. Many producers use paddle wheel aerators powered by an electric motor to stir the water and provide uniform oxygen distribution. The paddle should turn 15 to 30 times per minute to give adequate mixing action. Many producers use large air stones instead of paddle wheels. Air stones aerate the water more effectively than paddle wheels and may be placed below the baskets to provide more thorough mixing of the water around the egg masses. A continuous water flow of 2 1/2 to 5 gallons per minute is essential. Well water is preferred. It contains no predatory fish and less organic waste than most surface water sources. However, check your well water prior to hatchery construction to ensure that it meets recommended standards. Place collected egg masses directly into baskets made of 1/4 inch mesh hardware cloth. Baskets should fit the dimensions of the hatching trough and provide enough room for a single egg mass per compartment. The number of baskets and hatching troughs needed will depend on their dimensions, as well as on the number of broodfish you spawn, so plan ahead. Maintain water temperature in the hatchery as near 80 degrees as possible and within the range from 78 to 82 degrees. More deformed fry are produced at higher temperatures, and fungal diseases are more common at lower temperatures. Within the desired temperature range, eggs hatch in about 8 days. As incubation proceeds, the egg mass will turn from bright yellow to pink and then reddish-brown. By day 6, the eyes of the developing fish can be seen as the embryo spins within the egg. As the fry hatch, they drop through the mesh baskets and cluster at the bottom of the hatching trough. Fry in this stage are called sac fry. They are nourished by a yolk sac attached to their bodies and do not eat. Most producers move sac fry from the hatching trough to a separate holding trough 48 hours after they hatch. Gently siphon the fry from the bottom of the hatching trough into a bucket. The holding trough must contain water of identical quality as that in the hatching troughs. Sac fry remain at the bottom of the trough until the yolk sac is absorbed, about 3 days at the optimum water temperature of 80 degrees. Then they're called swim-up fry, because they swim to the surface and begin searching for food. Healthy swim-up fry are black in color and congregate in schools that actively search for food. When the first swim-up fry begin feeding, hatchery management becomes a 24-hour-a-day job. Careful monitoring is needed so that feeding can begin when the fry begins searching for food. Feed fry a diet that contains 40 to 50% protein 8 to 10 times per day, or about every 2 or 3 hours. Floating or sinking meal ground feeds may be fed around the edges of the tank. You can also attach small dough balls of feed to the sides of the tanks at the water surface. Siphon wasted feed and feces from the tanks daily to prevent the buildup of organic wastes. Fry are held in rearing tanks for 14 to 28 days. When they are between 3/4 inch and 1 inch in length, transfer them to nursery ponds. Fry stocked at high densities grow more slowly than those stocked at lower rates. The best stocking density for your operation depends on the size of fingerlings you need. Stock 150,000 fry per surface acre of water if 2-inch fingerlings are your goal at the end of 120 days. If you need 8-inch fingerlings, stock no more than 20,000 fry per acre. Producers of food-sized catfish generally want to stock 6 to 8-inch fingerlings in their grow-out ponds. They stock about 30,000 fry per acre. Whatever your ideal stocking density, you'll need an accurate estimate of the number of fry being stocked into nursery ponds. Record the volume of water that a known number of fry displaces. Use a graduated cylinder. Repeat this procedure on at least 3 different samples for improved accuracy. Then the right number of fish can be hauled to each pond by measuring the volume of water displaced in the hauling container. For good fry survival, keep the nursery pond dry for at least 7 days prior to being filled for stocking. During this time, smooth the pond bottom if necessary. Just before stocking, add enough water to the pond to establish a pool about 12 inches deep and not more than 30 square feet in size. Transport the fry from the hatchery in water that is slightly cooler than that in the nursery pond to reduce hauling stress. Stock the fry at night or early in the morning when the water is cool. Even small changes in temperature, pH, and dissolved oxygen can be lethal to fish of this size. Temper them by slowly adding water from the pond to the hauling container. Temperature should not change more than 1 degree per 10 minutes and pH should not change more than 1 unit per hour. Feed newly stocked fry as much as they will eat 3 or 4 times daily. It is better to slightly overfeed at this stage to ensure fast, uniform growth of fry. But make sure that the feed is being consumed and not sinking to the pond bottom. That can cause water quality problems. Watch carefully because feeding fry are difficult to see. Slowly add water to fill the pond. If the fry quit feeding as the water level rises, stop adding water until they become reoriented and begin feeding actively again. For the first 4 weeks after stocking, feed a finely ground, floating feed that contains 40 to 45% protein and at least 20% fish meal. Then switch to a crumble-textured feed with 40% crude protein. Gradually, train fry to accept a 3/16 diameter pellet. Plan on a transition period of 3 days to 1 week when changing feed types. To ensure a smooth transition, steadily increase the amount of the new feed type being mixed with the old until the switch is complete. Regardless of feed texture, always feed fry a floating feed that contains at least 36% crude protein. Some producers fertilize fry nursery ponds to increase production of zooplankton. Zooplankton are microscopic animals that provide an important source of supplementary food for growing fry. Combine enough granular inorganic fertilizer with organic fertilizers to supply a total of 1 pound of nitrogen and 3 pounds of phosphate per surface acre of water when the pond is full. Cottonseed meal, alfalfa hay, or old fish food will work. But begin adding the fertilizer when the first water is pumped in, not when the fry are stocked. Make 5 additional applications at weekly intervals. Fingerlings that have reached the desired size for sale or restocking in grow-out ponds should be harvested. Pick a time when water temperatures are neither excessively cold or hot, and use a bag seine to catch the fingerlings. Remove fish from the seine gently and quickly for transport to grow-out ponds. Now you're ready for the grow-out phase of the channel catfish production process. Management practices for producing food-sized channel catfish are presented in the Southern Regional Aquaculture Center video. If you want more specific information about catfish production in your area, contact your local extension agent or state aquaculture specialist.